In example 11, you are asked to interpret the given velocity time graphs and describe how an object would move to produce each of the given graphs. If you haven't already done so, take a moment and write down in words how an object would move in order to produce each of the given graphs. Okay, assuming that you have already done so, let's take a look at 11a. You have this velocity time graph with a sloping line straight up at this certain initial velocity. I'm going to label my axes here so I can be a little bit more specific with my description here. I can see that the object is starting off at an initial velocity of 2 meters per second, and it's moving away because it's got a positive velocity, and it is speeding up in the positive direction. So this is constant positive acceleration. So there you go. Object starting initial velocity of 2 meters per second, increasing its velocity at a constant rate because we have a constant positive acceleration. By the way, we don't know where the object is starting. All we know is what velocity is starting with. Okay, on to 11b now. Here we have a horizontal line. You should have stated that this is a constant positive velocity. So here I've written the object moves at constant positive velocity throughout the whole time period. This is zero acceleration. Remember that acceleration is the change in velocity over the change in time, which is the slope of this graph, and the slope of that graph is 0. All right, moving on to 11c, you may want to annotate this as well. Here we have an object starting with an initial velocity of 2 meters per second, and its velocity is decreasing at a constant rate. So we have an object starting with initial velocity of 2 meters per second, and it is decreasing at a constant rate in velocity, which is constant negative acceleration. Notice that at 2 seconds, the velocity is equal to 0. This is like a ball being thrown straight up in the air. It starts off with an initial velocity upwards of 2 meters per second, gets to the top of the path, which is at 2 seconds, and then starts falling back downwards with a negative velocity of negative 2 meters per second. Okay, and now 11d. This is an interesting scenario. You have a velocity versus time graph, but it's a curve now, and you won't see this very often in AP Physics B. If we were to take the slope here, for example, or the slope at the top of the path right here, these slopes represent the acceleration. So at the very top of the path, the acceleration is 0. Here, the acceleration is positive. And then over here, we have an acceleration that is negative. So in this particular case, our acceleration is never constant. It's always changing. So in this particular case, the acceleration is non-uniform. It's always changing. I suppose we could call it accelerating acceleration.